Imagine this. In the dead of night, every radio telescope on Earth suddenly lights up, capturing a signal so powerful it drowns out the cosmic static. It's not from our sun, not from a nearby star, but from a galaxy 2.5 million light-years away. Andromeda, our closest galactic neighbor. This isn't science fiction. It's real, and it's happening right now. At 3:47 a.m. Eastern Time on a quiet morning in October 2025, a second wave of mysterious radio signals from Andromeda hit Earth, stronger and stranger than the first. Scientists are calling it unprecedented. NASA's Deep Space Network scrambled to confirm it. Telescopes in New Mexico, Australia, and Canada locked onto the source. The signal wasn't just a random burst. It carried a pattern, a rhythm, like a cosmic drumbeat echoing across the universe. And here's the kicker. Moments after it arrived, Earth's magnetic shield flickered, as if the signal didn't just reach us but touched us. What could possibly send a pulse so intense it crosses galaxies and shakes our planet's defenses? Is this nature flexing its most extreme powers, or is something or someone trying to get our attention? Stick with me as we unravel this cosmic mystery piece by piece, from the first faint whisper 18 months ago to the mind-bending questions we're asking today. If you love diving into the unknown, hit that subscribe button and let's explore what could be the biggest discovery in decades. Because trust me, you won't want to miss what comes next. Let's start at the beginning. 18 months ago, in January 2024, radio telescopes at the Keim Observatory in Canada caught a fleeting signal from Andromeda's direction. It lasted mere milliseconds, a bright flash of radio energy labeled EFRB 240117. Fast radio bursts, or FRBS, aren't new. CHIME detects dozens every year, brief pulses of radio waves from galaxies billions of light-years away. Most are one-off events, like cosmic firecrackers. This one was different, not just because it came from Andromeda, a galaxy practically next door at 2.5 million light-years, but because it was a single isolated burst. Astronomers chalked it up to a magnetar, a neutron star with a magnetic field so intense it could erase your credit card from halfway across the solar system. A magnetar's crust can crack, releasing a burst of energy bright enough to outshine entire galaxies for a split second. Strange? Sure. Unexplainable? Not quite. The data was cataloged, a paper was published in a journal, and the scientific world moved on. But then this year, the second wave hit, and it turned everything we thought we knew upside down. Picture the scene at NASA's Jet Propulsion Laboratory. It's the early hours of October 2025, and the control room is buzzing. The second signal from Andromeda wasn't just a repeat, it was 50 times stronger than the first, clocking in at 140 Janskys, a unit of radio brightness. For context, the brightest FRB ever recorded, FRB 2022-0610A, peaked at just 3 Janskys from a galaxy over a billion light-years away. Andromeda's signal was from a source 50 times closer, which, thanks to the inverse square law, means it was thousands of times more intense. Imagine a flashlight so powerful that, from the moon, it outshines the sun for a moment. That's the kind of energy we're talking about. More radio power in 3 seconds than our sun emits across all wavelengths in an hour. Scientists were stunned. Dr. Vikram Patel at MIT's Kavli Institute ran the calculations 3 times, convinced his software had glitched. It hadn't. The numbers were real, and they pointed to something extraordinary. What made this signal even stranger was its structure. Unlike the chaotic bursts of a typical FRB, this one had order. NASA's newest AI, built on the same architecture Google DeepMind used for protein folding, dove into the data. Within minutes, it flagged something astonishing. The signal's polarization, the way its radio waves vibrated, flipped rhythmically every 200 milliseconds. Think of polarization like the orientation of light passing through polarized sunglasses. Natural sources like pulsars or magnetars produce random, messy vibrations. This signal was different. It shifted, then shifted back, in a precise repeating pattern. Dr. Emily Chen at the SETI Institute tested every known natural mechanism: plasma lensing, quantum vacuum effects, Relativistic beaming. None fit. The pattern was too clean, too regular, like a metronome ticking in the void. Could this be a new kind of physics? Or something we're not ready to name? Drop your thoughts in the comments. I'm dying to hear what you think. But the plot thickens. 4 minutes after the signal hit, at 3:51 a.m., something bizarre happened here on Earth. NOAA's Space Weather Prediction Center detected a ripple in our planet's magnetosphere, the invisible shield that protects us from solar radiation. For 8 seconds, the magnetic field compressed, shrinking inward by nearly 2,000 kilometers before snapping back. At first, scientists assumed it was a solar flare, a burst of charged particles from the sun. But the Solar Dynamics Observatory showed nothing. No flares, no coronal mass ejections. The sun was quiet. Satellites in orbit and ground stations from Alaska to Antarctica confirmed it. No other electromagnetic activity in that 4-minute window, except the Andromeda signal. Radio waves shouldn't interact with magnetic fields. They pass through them like light through a window. Yet the timing was unmistakable. Signal at 3:47, magnetospheric flicker at 3:51. Even more chilling, archivists at NASA's Goddard Space Flight Center found a similar blip 18 months ago, 8 minutes after the first Andromeda signal in January 2024. No one had connected the dots then. It seemed too subtle, too impossible. Now with two events, the correlation was undeniable. Something from 2.5 million light-years away was affecting Earth. Let's dive deeper into the signal structure, because this is where things get truly wild. NASA's ARI didn't just stop at polarization. It analyzed the signal's timing, the gaps between pulses. Each pulse lasted exactly 43 milliseconds, followed by silence. 86 milliseconds, then 172 milliseconds, doubling each time. This isn't just a pattern, it's a geometric progression, like the binary code computers use to encode data. The signal contained 12 pulse clusters, each with a varying number of pulses, 3, then 5, then 2, then 7. Dr. Sarah Brennan at Breakthrough. Listen compared it to every known astrophysical source. Pulsars tick like clocks, but their timing drifts. Magnetars are chaotic. Even exotic phenomena like plasma wake-field acceleration, where particles surf electromagnetic waves, don't produce such precise intervals across intergalactic distances. The precision was the problem. Nature is messy, but this signal was almost too perfect. Could it be a natural process we haven't discovered, like a cosmic particle accelerator the size of a galaxy? Or is it something engineered? Let me know your theory below, and don't forget to like this video if you're as hooked as I am. Now let's talk about the source. Andromeda is 2.5 million light-years away, meaning these signals were sent when our earliest human ancestors were chipping stone tools. Whatever produced them, whether a natural object or something else, was active 2.5 million years ago, firing bursts separated by what we perceive as 18 months. But here's the twist. In the source's reference frame, those bursts might have happened hours or days apart. The light speed delay stretches our perception of time. Scientists are exploring two main theories. First, Andromeda's supermassive black hole, with a mass 4 million times that of our Sun, could be cycling through accretion episodes, gulping down matter and spitting out radio bursts like a galactic heartbeat. NASA's Fermi telescope has observed a gamma-ray excess in Andromeda's core for years, possibly from dark matter or these episodic flares. The second theory points to a supermagnetar, a theoretical neutron star with a magnetic field so strong it warps space-time itself. Such an object could store enough energy for multiple bursts, but the math pushes quantum mechanics to its limits. Both theories are natural, but neither fully explains the signal's regularity or its interaction with Earth's magnetosphere. The energy scale is staggering. To produce a signal this bright from 2.5 million light-years away, the source would need to release more energy in 3 seconds than our Sun emits in an hour. Colliding neutron stars or hyperflaring magnetars can manage this, but both are one-time events. This source fired twice from the same spot, 18 months apart. That rules out mergers and strains magnetar models. Dr. Avi Loeb at Harvard put it best. When we see order in nature, like the hexagonal patterns in a crystal or the precise orbits of planets, there's usually a simple physical cause. But when order appears without an obvious driver, we're in uncharted territory. Scientists aren't saying aliens, extraordinary claims need extraordinary evidence. But the data is forcing us to ask uncomfortable questions. Is this a new kind of cosmic phenomenon, or the first hint we're not alone? Let's ground ourselves in what we know for sure. Fast radio bursts are real, detected regularly by observatories like KEIM. They're brief, powerful pulses from distant galaxies, often linked to magnetars or gamma-ray bursts, the universe's most explosive events. Andromeda's signals fit the FRB profile, but stand out for their strength, structure, and proximity. The magnetospheric flicker adds another layer of mystery. Radio waves shouldn't affect Earth's magnetic field, yet the timing suggests a connection. NASA's emergency briefing in October 2025 didn't jump to wild conclusions, but it confirmed something extraordinary. A source in Andromeda, 2.5 million years ago, sent a signal so powerful it reached us and possibly interacted with our planet. Whether it's exotic physics or something more deliberate, we're witnessing a phenomenon that challenges everything we know. So what's next? Scientists are watching Andromeda closely. Every major telescope on Earth is trained on its core, waiting for a third wave. If the 18-month gap holds, we could see another signal around April 2027. The questions are piling up. Is this a natural cycle, like a black hole's rhythmic flares? Could it be a supermagnetar pushing the boundaries of physics? Or is it a signal, intentional or not, from a civilization long gone? The answers could rewrite textbooks or change how we see our place in the cosmos. I want to hear from you. What do you think this is? A cosmic coincidence or a message from the stars? Drop your thoughts in the comments, hit that like button if this mystery has you hooked, and subscribe to stay updated as this story unfolds. Share this video with anyone who loves space, because the universe just got a lot more interesting. And if you can't get enough of cosmic mysteries, check out our other videos on black holes, Mars missions, and more. The universe is knocking. Let's keep listening.